All right, so let's look at number 21. Number 21, it says that the function 200t plus 10,000 represents the growth, the population of a town after t years of growth. So this is p of t. And then they're asking us to find the inverse. So for this one, you need to remember the steps for finding an inverse. So instead of p of t equals 200 plus 10,000, I'll write y equals 200t plus 10,000. And then switch the y and the t, in this case it's not x. So this is going to become t equals 200y plus 10,000. And then I'm going to solve for y. So solving for y, I'm going to subtract 10,000 and then divide by 200. So that's going to be my y. So this is the inverse. This is p inverse of t, and this is t minus 10,000 over 200. All right, so the answer is D. Okay, 22. It says to find f of g inverse of g of negative 2. So this is f of, let's see what is g of negative 2. Well, this is the function g. When x is negative 2, g of negative 2 is 4. So this is going to turn into f of 4. So now you look in the function f. This is the function f. When x is 4, the output is 2. So the answer is 2. Consider the polynomial function. This one. Find all the x-intercepts. Remember, the x-intercepts or the zeros. So basically, it's already in factored form. So from this one, I get that x equals 0, because then 2 times 0 times all of this stuff, it's going to give you 0 out. From this one, I get x minus 7 equals 0, which gives you that x equals 7. From this one, I get that x plus 5 equals 0, which will give you x equals negative 5. From this one, I get x squared plus 9 equals 0, which gives you that x squared equals negative 9. This is not going to give you x-intercepts, no x-intercepts from this one. And then the last one, x squared minus 16 equals 0, will give you that x squared equals 16, which gives me that x equals plus or minus 4. So the zeros are 0, 7, negative 5, and plus or minus 4. So the answer will be C. Alright, number 24 says that P is directly proportional. So directly proportional means that you're going to have a constant times something that it. So P is directly proportional means P equals K times whatever is directly proportional with. So it says it's directly proportional to both C, so it's going to be K times C, times D squared. D squared. And they are telling us that K, the constant of proportionality, is 1/4. So basically, the formula is going to be P equals, instead of K, we put 1/4. C D squared. So the answer is D. G inverse of 4. G inverse of 4. Basically, I'm looking at G of what equals 4. G of what equals 4? Well, notice that G of negative 2 equals 4. Well, I don't know what just happened, but G of what equals 4? So you're looking in here and you see that at negative 2, the function G is 4. So therefore, G inverse of 4 equals negative 2. All right, write the equivalent statement in logarithmic form. So this is 10 to the x equals 5. Remember, log form, they keep the base, so the base is 10, and then they switch the input and with the output. So it's going to be log the output becomes the input in here, and then this is going to go there. So it's going to be log base 10 of 5 equals x. But we don't write the base 10, so this is simply log of 5 equals x, which is D. Find the solution of this equation. So first thing we're going to do is divide by 3 both sides. So we're going to have 10 to the x equals 15 divided by 3, which gives us that 10 to the x equals 5. So now to solve for x, we have to do log so that the exponent comes down in front. So we're going to take log of both sides. And now the exponent comes down in front. So you will have x times log of 10 equals log of 5. But log of 10 is 1. So basically what we have is that x equals log of 5, which is B. Alright, next, find the exponential model f of x that describes the situation. A sample of 1,000 insects is multiplied by a factor of 3/5 each week. So basically, the model is y equals c times a to the x, where c is the initial population of 1,000, and the factor is 3/5, so a is 3/5. But now you gotta, the factor a is 3/5. What is the rate now? Well, you gotta recognize that 3/5 is 0.6, so a is 0.6, but that means that the rate is going to be a minus 1. So the rate is going to be 0.6 minus 1, which gives you negative 0.4. So the rate, it's a decay because it's negative, so the rate is going to be 40%. So decay rate at 40%. So this is the answer. The population of a certain rodent at a dump site can be modeled by this, where t is the number of years since 1963. So find the population in the year 2000. Basically, we are asked to find, in the year 2000, t is 37, because 37 years after 1963 means the year 2000. So basically, I'm just going to put t equals 37 in there. So when you plug in t equals 37, 683 e to the power 0.03 times 37, we get 2072.4. So it will be this one. All right, and the last multiple choice says a company that manufactures small canoes has a fixed cost of 24,000. It costs 100 to produce each canoe. So your cost function is going to be a linear function. It's mx plus b, where b is your fixed cost. And then m is how much it costs for each x, for each canoe. So m is going to be 100. X is the number of canoes produced. Alright, so that means that our cost function is c of x equals 100x plus 24,000. Okay, now let x be the number of canoes, not if canoes. What is the cost and the revenue function? So what about the revenue function now? R of x is how much you get if you sell x canoes. So it says the selling price is 400. So basically the revenue function is going to be 400x. Well, if you sell one canoe, you get 400. If you sell 2 canoes, x equals 2, you get 800, and so forth. And then the break-even point means where the cost equals the revenue. So you're just going to write down the cost, 100x plus 24,000 equals 400x, and then solve this for x. So you'll subtract 100x, so you'll get 300x equals 24,000, so x is 80. Okay, x is 80, so that's the number of canoes, 80 canoes. Now, if x is 80, what is the cost? But the cost in this case equals the revenue, so I can input x equals 80 in the revenue function or in the cost function, but the cost function is more complicated than the revenue function. So to get the second coordinate of the break-even point, we're gonna calculate the revenue at 80. So the revenue when you sell 80 canoes, so it's gonna be 80 times 400, which gives you 3,200. So the break-even point is this one. Alright, so 400, looks like the answer is this one.